Hello everyone. Today's question is to city scheduling. There are 2 people a company is planning to interview. The cost of flying the eighth person to city A is costs I0 and the cost of flying the eighth person to city B is costs I1. Return the minimum cost to fly every person to a city such that exactly n people arrive in each city. Now we will move to pen and paper and understand this question more clearly. So now we will understand this problem statement using this given example. Suppose here we have four people. We have four people. Okay, we have to send four people in different cities. That is, this is indicate for city A and this is for city B, and subsequently A, and this is for cost to fly city B. Okay, so what we have to return, we have to send two people. This is 4, so we have to send half people to city A, we have to send two people to city B, and two people to city A. We have to send equal number of people to each city, two people city B and two people city A, with another condition, with minimum cost. Okay, so with minimum cost we have to, so possible minimum cost, we have to maintain possible minimum cost. Means first what we have to do, we have to first we send the people A, we have to send first person to city A. For in this chunk we choose city A, and in this chunk we choose city A again, cause this cost is cheaper than city B, and in this case also, in this case we choose city B instead of city A, cause 50 is cheaper, this 50 is cheaper than 400. So in this case we choose city B, cause if we fly city B then it will be cheaper than city A. So in these two cases we choose city B, cause this is cheaper, and in these two cases we choose city A. Okay, city A. So two people for city A, and here two people for city B. Okay, now we will able to equal number of people to city A and city B, that is 10, 30, 50 and 20, that is 110. So using 110 cost we can able to send 4 people city A and B, two people to city A and two people to city B. I hope problem statement is clear to you. Okay, now we will move to solution. Here I will modify the data. It is, instead of 20, here I will use 40. Okay, 40. Okay, so what I will do here, first I will send all people to city A. Okay, first I will send all people to city A and then I will calculate the cost. Okay, first I will send all people to city A. Here all people is 4. We will send 4 people to city A, and this will cost this will cost 470. Okay, and now what I have to do, here I send all people to city A, but in our problem statement we have to send equal number of people to different city. Means we have to send two people. We have to send two people to city A and two people to city B. So now we need to choose half of them. Now we need to choose half. Means we have to choose two cost from this four cost. Okay, we have to choose only two cost. Okay, and now what I will do, I will calculate the cost for CTB also. So I'll calculate the cost for CTB. So if we send all people in CTB, and that is 20, 200 plus 50 and 40. It is interesting. Okay, so now what I will do, I will choose the better option. Which city cost is cheaper? So for these two, if we send the people instead of city A, then it will cheaper. No, it will not cheaper, because we have to pay extra 10 rupees, because this is plus 10. And if we send for this, if we send people to city B, it will cheaper. No, it's not. So we have to pay extra 170, but we have to calculate the minimum cost. Here we have to pay 170, so we will not go to this city, because this is extra cost. We have to pay extra cost. Okay, now we will move to next. So that is this will cost 400. Whoa, this is so costly. And if we send people to city B, it's just only 50 rupees. Okay, so it's just only 50. So here we can able to save 350. Okay, so here we can able to save 350. So we should go with B, because this B will, if we go to city B, then we will save 350. Now we'll move to next. And here if we go to city B, then we have to pay 10 extra. Okay, we have to pay 10 extra. Okay, 10 extra. Just here we save the cost, but in 3 cases we have to pay extra. But we have to choose two people. We have to send two people to city B and two people to city A. And here we choose the minimum one cost from this 3 cost, because we know this is costlier. But we can't choose 3 people. We can't send 3 people to city A, because in this problem statement there is a rule. We have to send equal number of people to different city. So here we can go with, we'll choose city B for this case and this case, and choose city A for this and this. Okay, means we will choose city B for this and for this, and we will choose city A for this and this. 30 30 and 20 50 70 and 60. Okay, so it will cost 60 and 70, that is 130. And we can able to extract the answer from this also. 470 minus 350, and choose the minimum of this 3, that is 10 plus 10, that is also 130. So this 130 is our desired answer. So now I will move to implementation part. In our implementation, first I will import a heap queue. Instead of sorting this, I will build a heap queue. So in this different list we will store the cost difference between CTA and CTP, and mean cost we store all the cost of CTA. If we send all people in CTA, mean cost will hold in different list. We append the difference between CTB and CTA, and mean cost will hold the cost of CTA. And we now we send half people to CTB also, and we will reduce the cost, mean cost. And as I already told, instead of sorting I will use here heap queue to save to improve our time complexity, cause build heap queue cost is order of n. And I will add the mean cost plus heap q dot heap pop different. Okay, diff. And now I will return mean cost as our answer. So now I will run it. Yeah, running successfully. Now I will submit it. Yeah, got accepted. Thank you for watching this video. If you are new to this channel, please consider subscribe and don't forget to hit the bell icon.